All right, good morning or good afternoon, good evening, or whatever time you're tuning in. This is day one lesson for Unit 3. All of you guys tested Monday, Tuesday, and then part of Wednesday, Thursday as well. So this is everybody gets this particular lesson online. It's a pretty easy one, so I think you'll be able to handle it without being in person. And then we'll kind of get back on track to doing the normal stuff on Wednesday, where the A people will see me in person, and I'll post the video for the Bs and the virtuals, and back we go after that. And obviously next week we're all back in person. Well, the face-to-face people are back 100% of the days, and the virtual people are still 100% virtual. So that's kind of looking ahead. So let's just jump in with rational operations. We're going to start with the really easy stuff. Again, day one of Unit 3. Let's start with something that I think we all know how to do. 3/4 plus 1/3, hopefully. Right? Common denominator of 12, I guess. So if we get them both to be 12, then we can add the numerators. This is basic stuff, but we're going to use it for more complicated things in a moment. So for now, let's just do an easy one. Whoops. So let's multiply the top and the bottom of this one by 3. That'll get that guy to 12. And top and bottom of this guy by 4. That'll get him to 12, or the bottom to 12. So we got 9/12 plus 4/12. And then you keep the denominator, add the numerators, 13/12. So, I mean, that's whatever, middle school stuff there, maybe even before that. So hopefully you're good on that. But that kind of thought process is we're going to use today with more complicated things than just numbers. We're going to do the same thing with variables, with expressions, x's and x plus 2's, and things like that. But I wanted you to see an easy one because we're going to do the same thing. Get a common denominator, make the denominators match, add the numerators. All right, the assignment, we're just going to do some together off the assignment. The assignment's in the folder. It's Unit 3, Worksheet 1. We're just going to do some of them together. In fact, those are the ones we'll do together, 1, 2, 5, 8, and 10. So number 1, 6x and 8x. I need a common denominator. It will definitely include an x. And then I need a common denominator for 6 and 8. Some people always multiply these, and that works, but that's not a least common denominator. So I'd really like a least common denominator because that would just make my life a little easier. Smallest number that both of those would go into, let's see, 24. They both go into 24. So let's use 24x. How you come up with 24x is a matter of experience and just kind of math sense about you. If you get stuck, you can always just multiply the two together. You'll get a bigger number than you need, and you'll have to work with big numbers. But eventually you'll get down, you'll still get the same answer at the end. All right, so I'm aiming for 24x. That's kind of my target denominator. I want both of them to be 24x. So this first one needs a 4. Whatever you do to the bottom, you got to do to the top. Second one needs a 3 to get to 24. Again, whatever you do to the bottom, you got to do to the top to make them match. So both denominators are now 24x. In fact, you can kind of be lazy and just write it as one denominator, because that was the point all along, was to get one denominator. The top is now 4 times 7 is 28. 5 times 3 is 15. So 28 plus 15 is 43 over 24x. That doesn't reduce, but we should always look just in case. So we're done with number 1. Number 2. Again, more complicated, but same process. I need to get a common denominator. And I think my common denominator for this one, the only way to do it is to just use both of them. I can't subtract 2 from this one and add 2 to that one to make them both x, because you can't add or subtract. You're only allowed to multiply. You can say, well, I multiply this one by -1, and that would make it a -2, and it would, but it'd make it a negative x. So I'm kind of stuck. There's really no shortcuts around this. I'm just going to have to use both of them for the common denominator. So the first one needs an x plus 2 to make the denominators match, which means the top one needs an x plus 2. The next one needs an x minus 2, so it gets an x minus 2, top and bottom, so that now their denominators match. So again, I'm going to be lazy and just write one denominator. That's not being lazy, that's the whole point of the problem, is to get one denominator. The top, if I distribute the 6, I get 6x plus 12. For this one, I'll distribute the x. Be careful, if this is a minus sign here, you'll need to distribute the minus sign as well. So plus x squared minus 2x. I distribute the x. And now I just need to clean up the top. So like terms, x squared plus 4x plus 12 all over x plus 2, x minus 2. Again, you're adding fractions. You've been doing this for years. Now we're just making it a little more complicated with some crazier denominators than we're used to. Skip down to number 5. Right, well, this one, we need to factor this guy first to see what the factors are down there. X minus 2 and x plus 1. I'm going to spread this out a little bit so that I'll have room to write extra denominators, because I need them to match. I need all my denominators to be the same. One silly way to remember to think of this is denominators are kids in the backseat of the minivan when snacks are handed out. They all want the same snack. It doesn't matter what they have, how much they have, if it's better than the other guys. It doesn't matter. They all want the same. Like, well, if my brother has that, then I want that. But if he has that, I want that too. So they all end up getting the same thing. So this brother here, he looks at this first guy, he says, well, I want an x plus 1. Why can't I have an x plus 1? It's like, well, fine, you can have an x plus 1. And this third brother over here looks at the first two guys and like, well, that's not fair. I want an x minus 2. So you give in, and you're like, okay, you can have an x minus 2 as well, as long as you give it to the top and the bottom to keep the fraction the same. Now all the denominators match. That's the goal, to get a common denominator. Once you have a common denominator, you don't have to write it 3 separate times because it's now in common. So x minus 5. Here we go with the minus sign, so let's distribute the minus sign. Minus 3x minus 3. Over here we'll have to FOIL. So 4x squared minus 8x plus x minus 2. So the chunk of this problem is done. We still need to clean up the top though. So looking for like terms, there's only one x squared term. The x's, there's quite a few here. So 1 minus 3 is negative 2, plus 4 is positive 2. Whoops, that's an x squared. Start over. 1 minus 3 is negative 2, minus 8 is negative 10, plus 1 is negative 9, so minus 9x. Yes, double checking that one. And then the numbers that are by themselves, minus 5 minus 3 is minus 8, minus 2 makes minus 10. All over our common denominator. So a little bit more complicated, but it's the same thought process. Get the denominators the same, and then fix the numerators as part of that process, and then clean up the top, leave the bottom alone. Alright, number 8. This gets a little bit different here. I'm dividing with fractions, but to divide with fractions, hopefully you remember keep it, change it, flip it. Keep it, change it, flip it. Of course, the its aren't real helpful because, like, what are we talking about? Keep what, change what, flip what. So keep the top the same, change it to multiplication instead of division, and flip the bottom. So keep it, change it, flip it is quick to say and easy to remember, but it's maybe not as helpful as it could be because you got to remember what the it's you're referring to. So keep it, meaning keep the top. Change it, meaning change it to multiplication. And flip it, meaning flip the denominator. And then now you've got a problem that you can reduce. You might need to factor first to see if something will cancel. Like you can factor out a 3. And then things that are eligible to cancel are things that are being multiplied. Okay, so this x plus 3 is a chunk of stuff that's being multiplied. So I can cancel out the x plus 3's. The x's will cancel. Those will go away. And the 6 over 4 will reduce. Just be careful when you reduce. So 6 over 4 would become 3 over 2. So goodness, we lost a lot of stuff in this one. And then be very careful with what's left. Be neat as you do these problems. A lot of people go too quick, and then they get to the end and they can't tell what they canceled and what they kept and what they reduced. So be neat so it's easy to see what's left is 3 times 3 in the top. And in the bottom, nothing but a 2. So it started out really complicated and reduced down to 9 halves. All right, let's do one more. Number 10. All right, keep it, change it, flip it, but you can't really do keep it, change it, flip it until it's one fraction over another fraction. So I need to fix the top, meaning add the top, fix the bottom, meaning add the bottom, and then keep it, change it, flip it. So I've got to have one fraction over another fraction, and then I can use keep it, change it, flip it. So looking just at the top, and some people go so far as to even just cover up the denominator here. Like I don't want to get confused with what's going on. I'm just working with the numerator, and I want to add fractions. So this one needs a denominator of 3. So my top then becomes, let's see, my denominator is 3. My numerator is now x minus 12. So x minus 12 over 3 is the same thing as x over 3 minus 4. It's just now one fraction instead of two pieces. Fix the top, we did that. Next, fix the bottom. And again, if you need to cover it up so you don't get distracted and you're focused only on the bottom, you can do that. Let's see, so the bottom, I want to add those, so I need a common denominator. This first one needs an x, but if it gets one in the bottom, it gets one in the top. My common denominator is x. My numerator is 5x plus 1. 5x plus 1 over x is the same thing as 5 plus 1 over x, right? Because you could divide the x into this one, but not into that one. So this is the same thing as this, but now it's in one fraction. So now we're sort of eligible to use keep it, change it, flip it. So fix the top, fix the bottom, and now we can do keep it, change it, flip it. So keep it, x minus 12 over 3. Change it to multiplication. Flip it, so x over 5x plus 1. Now we look for things to cancel, and there's nothing eligible to cancel. Please do not cancel the x's right here, right? Because that x is part of 5x plus 1. So this thing would have to cancel as a whole piece, a whole chunk of stuff. Same thing with the 12 and the 3. Please don't tell me that 12 divided by 3 is 4. I mean, 12 divided by 3 is 4, but you can't reduce that because it's all over 3. So you can't reduce, you can only reduce factors, not things that are being added and subtracted. So nothing is eligible to reduce here, so this is kind of a bummer. There's really not much we can do. Just stick them together. X times x minus 12. Remember when multiplying, you just multiply across the top and multiply across the bottom. Nothing reduces, so there we go. All right, your assignment is the rest of them. We've done not quite half of them. You got 7 more left to try. So do those, and on Wednesday I'll answer questions of those, and I'll post a video of me working a few more. But I think that should get you off to a good start for today. Thanks and good luck.